All right, once again, welcome back to another exciting day mathematics. Whoop, whoop. Warm up number 37 is on your screen. Number 1 is complete the square and factor, and the polynomial given is x squared plus 16x. 2 says simplify, square root of negative 81. Number 3 says factor by grouping, x squared plus 8x plus 12. And number 4 says find the inverse function f inverse of x for the given function f of x, and the given function is f of x equals 5x minus 20. All right, I'll give you guys some time to complete that. Copy and go. All right, so the answers for the warm-up are on the screen. Make sure you check your work, and let's move on. All right, our agenda for today, we got warm-up number 37. We're still working on transformation of functions, and today we have, for Homeplay, 7 transformations only. Only, see, it makes it seem like very little, right? Only 7. So make sure you get that work done. Remember, the more practice we get, the better we're gonna be with once we introduce more functions. Let's move on. Asynchronous session code for Nearpod is 8SRQA. 8SRQA. Okay. And your previous Homeplay, it's on the screen. Make sure you turn that into Canvas. Go there right now. Turn it in. And remember, guys, before we meet every time, make sure you take pictures of all your stuff. Try and see if you can fit all of them in one document when you submit. If not, then that's fine. But as long as you have it formatted to JPEG or anything similar to that, because if you have any other format, it might not read it. And your Homeplay for tonight is on the screen. It says Homeplay, do the indicated transformations to the following functions. And we have graph f of x equals x, f of x equals x squared, and f of x equals x cubed. So 3 different functions with a domain -2, -1, 0, 1, 2. Then it says, given that g of x equals a times f of parentheses x minus h close parentheses plus k, transform each of the functions when h equals 6, k equals -2, and a equals 2, and that is in blue. Then another is h equals -3, k is -5, and a is 1/2, that is in red. And the last problem reads part B, graph f of x equals x cubed, given g of x equals negative, and then we have a fraction. On the numerator, we have f of parentheses x plus 4 close parentheses over, in the denominator, we have 3. That's your Homeplay for tonight. So once again, make sure if you can copy it from the screen, make sure you go with your synchronous code and copy it on your own. And let's move on. Our objective for today, I can transform a function using different parameters. I can transform a function using different parameters. Now, some of you are still turning in your work. That's fine on Canvas. So for that, I'm going to give you some time to fill out your Freyer model, which is on the screen. What is a function? Your own words. One example, and a hashtag. And that'll give you extra time to turn in your Homeplay. Oh. All right, here we go, guys. So last time we left off, and we had our general rule of g of x equals a times f of x minus h, close parentheses, plus k. And I left you guys some practice for that. And hopefully you got a hold of it. And so far we have 3 parameters. Right now we're gonna do a couple of more exercises just to make sure that we got it using these 3 parameters. Here we go. So on your coordinate plane, your coordinate plane next to it, I want you to graph f of x equals x. F of x equals x. You're like, that's it, Mr. Q, that's it. So if I was to give you just that, what would you do to graph that? Angie, what do you think? What would you do to graph that? You there, Angie? Yeah. Is my mic on? Hello? Yeah. Esmeralda, help her out. What would you do to graph that? Okay, Alberto, go. Since you're trying to chime in, go.
I'm undecided. I'm sorry. It's because I don't know if it's okay to interrupt. Use the domain to like graph it.
Yeah, what domain would you use?
Well, it doesn't specify, but from -2 to 2.
Let's go. You remind me of me in kindergarten. Yes. So -2, -1, 0, 1, and 2, and then you graph that. Yeah. That's why I've been graphing using that domain specifically so that your muscle memory kicks in. And did it kick in? Yes. However, look what it says. I'm going to show you the next step after we graph that. It says, given that g of x equals a times f of x minus h plus k, which is our general rule, write the new transform function when a is 2 and k is -5. Then we're going to graph the transformation. So that means we first need to graph the original function. So let's do that one together. So Alberto said, well, we need a domain, Mr. Q. All right, so we got x, f of x. Domain -2, -1, 0, 1, 2. If I was to substitute these in here, we end up getting the same thing over here. So it's -2, -1, 0, 1, 2. You're saying, why, Mr. Q? Because there's nothing, look at x. Is there anything multiplying or being added here to x? No, it's the exact same thing. So let's graph this. -2, -2, -1, -1, 0, 0, 1, 1, 2, 2. Okay. There it is. All right. So next, they want us to write a new transform function when a is 2 and k is -5. Okay, writing utensils down, look up to the screen. Okay, here goes the process. Ready? So if they want us to write the transformation now, I'm going to write my general rule first. What's my general rule? My general rule is g of x equals a times f x minus h plus k. Look up, please. However, let's look at the function here. Does it have an exponent here? Is it a quadratic or cubic? No, it's just an invisible one. So that means here on the parentheses, I don't write an exponent here. Look up. I don't write an exponent there because it's an invisible one. Okay, so there's my general rule. Now that I have my general rule, I'm going to substitute, or I'm going to write underneath the parameters that they give me. What do they give me? They give me A2. Here's A, and it's 2. What else do they give me? K. K is -5. K is -5. Do they give us anything else? No. So what does that mean? That we have no H. So underneath H, I want you to put a 0 and cross it out. Now that we have that, let's rewrite our transform function. Here we go. G of x equals 2 Do we need to write the F for function? No, not anymore. When we don't have an H, look up to the screen really quick. When we don't have an H, we don't need the parentheses. So I bring down the X. Make a note for yourself. If you want right here, asterisk, heart. No parentheses when no H, or no H, no parentheses, whatever note you want to make. And then bring down the last part, -5. All right. So looking at K, what is K going to do to all the points, Christy? Which direction are we moving with K according to the number that they gave us?
The left 5.
Actually, K is which direction? Up or down?
Oh, down 5.
Yes, down 5. So put an arrow so that you can remember that at the end we're going to move that 5 steps down. All right, so which is the only one that we need to worry about, guys? The multiplier. What is our multiplier? A. So we're going to add a column right here. And then we have 2f of x. Okay. All right. So what do I write here? Christopher, tell me what you write here.
-4.
-2.
0.
1,
2. 4.
Yes. All right, let's graph that. -2, -4, -2, -4, -1, -2, 0, 0, 1.
Mr. Q, instead of the 1, shouldn't it be a 2? Sorry.
Oh yeah, I did that to see if you guys were paying attention. See what I did there? Pretty good, huh? You guys on your toes. All right. So let's graph that. I'm going to graph it in black, just so that I remember that I'm still not done with the transformation. All right. So we're done with the multiplier. What did it do? It stretched it vertically. Do you guys see that? That it stretched the original one vertically? Yes, Mr. Q. So what do we do at the end? Octavio. Octavio.
What was the question? Excuse, sorry.
What do we do at the end? Bianca, help him out.
We find the g of x by going down 5.
Yeah, the last step is to go down 5 because that's the last parameter. Each of these points, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And 1, 2, 3, 4, 5. We graph our line. And this is our g of x. So if you notice, guys, what's the only difference from what we did in the previous home play to this one? Well, this one, we're rewriting our transformation, and then we're graphing it. Okay? All right. Show me with fingers. I'll come to you all with these. 1 being the lowest, 5 being the highest. 5, 5, 5, 5 fours, 5. Okay, yeah. All right, let's move on to the next one. Once again, this is pretty much, I'm doing this as practice of what you did before. We're just adding the writing the transform function. Okay? Here we go. Example super cube. it says graph f of x equals x cubed. Get that set up. All right, well, Roman, so what would we do, what would you do in order to graph that function?
I'd start with the table and with the domain of -2 to 2.
Yeah, let's go. That's true. So we're getting this, right? We're getting the process. You need a table from -2 to 2. Okay, and also write the next instructions, which is given that g of x equals a times f of x minus h plus k, write the new transform function when a is 1/4, h is 5, and k is 3, and then we're going to graph. And hold on, there's a little typo right there. Let me get that out of the way. There it is. All right. So let's graph that. Let me get my table. So we said -2. So now it has a cube. So that means -2 cubed. It means -2 times -2 times -2. -2 times -2 is +4 times -2. That's -8. -1 cubed is -1. 0, 0, 1, 1, 2, and 8. Let's graph that. -2, -8. -1, -1. 0, 0. Oh my goodness, computer. Zero, 0, 1, 1, 2, 8. Okay. All right. So there's our function, our parent function. But now they want us to write the new transform function. So what is the first thing we need to write, guys? The general rule. So I'm going to do that right here in blue. We got g of x equals a times f of x minus h plus k. However, what's missing on the general rule? My exponent. What exponent are we using for the function, guys? Cube, the 3. So that goes right there. All right. So let's label the parameters that they give us. What do they give us? I'm going to do that in red. Well, they give us a being 1/4. I'm going to write that right here underneath. What else? H is 5. All right, which is right there. And K is 3. K is 3. All right, let's rewrite this. G of x equals 1/4. Do we need to write the F? No, so parentheses. Do we have an H? Yes, so parentheses, x minus 5 cubed, and then plus 3. So which direction are we going at the end? Let's see. Nathan, which direction will we do at the end? What would be the last 2 things we do?
Hold up.
Hold up, okay.
I guess you're gonna graph it. Oh no.
Yeah, but which direction?
Oh, so you're gonna go up, right, and right 5.
Okay, right 5, you said, and what else?
Yeah, and up 3.
And up 3, that is correct, thank you. So put arrows on that so you can keep that in mind, guys, for at the end. 5 to the right and 3 up. So which is the only thing we need to worry about? The multiplier, which is what? A. So we add a column right here. We do 1/4 times f of x. Okay. So 1/4 f of x. So f of x are these values right here, -8, -1, 0, 1, 2. So let me just show you the work for the first one. The first one is 1/4 times -8, which is -8/4, which is -2, -2. Next one, 1/4 times -1, that's -1/4, then 0, then 1/4, and then 2. Let's plot those points, -2, -2, -2, -2, -1, 1/4, -1 and -1/4 is about right there. 0, 0, 1 and 1/4, and 2, 2. I'm gonna graph that in black to indicate that I'm still not done with the transformation. And what do you guys notice? It compressed vertically because it was a fraction. It compressed. Are we done? No. As Nathan said, we need to move it 5 to the right and 3 up, each of these red points. So I'm going to start with this one. 1, 2, 3, 4, 5. 1, 2, 3. The next one is at 1/4, -1/4, and I go 1, 2, 3, 4, 5. 1, 2, 3. This one, I'm going to go 1, 2, 3, 4, 5. 1, 2, 3. This one, 1, 2, 3, 4, 5. 1, 2, 3. And this one, 1, 2, 3, 4, 5. 1, 2, 3. And this is our g of x. All right. Show me your friends what come to you with these so far. 5, 5, 5s, 5, 5, 4s. Okay. All right. So that's pretty much the first half of the home play. Okay. Now, the last problem on the home play is just practice on rewriting some of the functions. But what I'd want to do before that, I'm going to do a quick introduction to a new parameter. So today's going to be one of those, just like, I don't know, when you guys introduce people to some other people that you just go, oh, this is so-and-so, so-and-so, oh, hi, hi, that's it. So that's going to be today. I'm going to be students, parameter, parameter, students, okay? So here we go. So first things first, on a new coordinate plane, it says the graph of f of x equals x cubed is shown. So here it is. So go ahead and do that on a new coordinate plane, please. So it says, example 2q, the graph of f of x equals x cubed is shown, and the reference points given are -2, -8, -1, -1, 0, 0, 1, 1, and 2, 8. And then you graph your function. Do that. I'll give you some time to set up. All right, so it says the graph of f of x equals x cubed is shown, and there it is. We have already have plenty of practice graphing these. But look at the next part that they're going to give us now. It says graph g of x equals f of parentheses 1/2 x. Write that down, and then we're going to look at it through the lens of our general form, okay? All right, so let me write my general form so that everybody is aware as to what we're looking at. So my general form is g of x equals a times f of x minus h plus k. Since we're dealing with cubic, so I'm going to write a little cube right there. And this one is missing the cube, so I'm going to write it right here. There it is. Okay. All right, so looking at this transformation that they want us to graph through the lens of this general form. Question: for this transformation, what parameters are missing? Look at it, look at the general form, and look at this one. Don't say it out loud, let people think. All right, let's see. What one parameter do you see missing? Let's see, Matthew, what one parameter do you see missing?
I don't see K.
Okay, so we don't have K. So let's cross it out because there's nothing after the parentheses. Okay. What else do you see missing? Anthony, what do you think?
A.
A, there is no A, so cross it out. What else are we missing, Addie?
H.
H, so I'm gonna get H out of the way, including that negative. So if we look at our general form, look at it, all the three parameters that we did previously, they're not here. So now, what does that mean? We have a new parameter. And where is it located? Inside of the parentheses next to the X. So today I'm going to show you what that does, okay? So before we continue, let's quick recap. What did K do for our functions? It moved them either up or down. How about H? To the right or to the left? How about A? Stretched or compressed vertically. Okay, so with that said, let's graph this to see what it's going to do to the original one. So to graph it, we need a table, don't we? So yes, so let's do X, f of X. We have -2. So basically we're just getting these points here, -2, -8. -1, -1. 0, 0, 1, 1, 2, 8. Which are these? Okay. All right. So now we're going to find out what this does to our function. Let's see. We got a column right here. And we're going to write this, f parentheses 1/2 x close parentheses cubed. So now look up pretty please. Now this is where some of you make a mistake. Look up please. Some of you, your brain, what it wants to do is what we've been doing previously, multiplying f of x, which is these numbers right here, -8, -1, 0, 1, 2, by this multiplier. However, that is not the case on this one. Why not? Because the multiplier is inside of the parentheses with what? X. So therefore, now we're going to multiply the 1/2 times all the X value. So I want you to draw an arrow so that you can show what we're going to substitute in there. And of course, at the end, we're going to cube. So let's see. So I'm going to do the first one. I'm taking -2 and I'm doing the entire process. So we got 1/2 times -2 cubed, which is 1/2 times -2, that is -2/2 cubed. What is -2/2? That's -1 cubed. And what is -1 cubed? -1 times -1 times -1 is right here, sorry, -1. All right, let's do the next one. The next x value is what? -1. So we do 1/2 times -1 cubed, which is
0.125.
what's that?
0.125.
Yes. So we got -1 cubed is 1, 2 cubed is 8. So I'm going to leave it as a fraction, -1/8. Next, 1/2 times 0 cubed. And of course, that is 0. And the rest are going to repeat. 1/2 times 1 cubed is 1/2 cubed, which is 1/8. So let's see, 0, -1/8. This is +1/8. The next one was -1. That means this is a +1. All right, so let's graph that and see what it did to the original function. -2, -1, -2, -1. Next one, -1, -1/8. -1, -1/8. It's close to the x-axis, which is right there. Next one, 0, 0, 0, 0. Next one, 1, 1/8, 1, 1/8. And 2, 1, 2, 1. So I don't know if you notice, if we were to get the original function and it's a rubber band, what do we need to do to make it look like that red one? Stretch it in which direction? Horizontally. You guys see that? Now it's stretching horizontally. Today's parameter is this next parameter that's going to do stuff to it, but horizontally. And how does that look like now in a general format? Let me show you the general form. Write this down. Bam. G of x equals a times f of parentheses 1/b x minus h close parentheses plus k. Some of you are like, man, Mr. Q, it looks like really like fun. Oh, yes. So as you're writing that down, let's recap in regards to what each piece does. Here we go. I'm going to circle the K. What does that do? It goes up if it's positive or down if it's negative. H, what does H do? H, Mr. Q, goes to the right if it's positive or to the left if it's negative. That is correct. All right, let's see if you follow along. Here we go. Then we went to A, and what did A do? A stretched or compressed. Which way? Vertically. Right? It stretches or compresses vertically. And today we introduced a new one. And what was the new one? B. But notice B is in a fraction form where 1 is in the numerator and B in the denominator. And what does that do to the function? Who's got it? Let's see. Jaziel, pass it to someone.
Hayden.
Hayden, what does it do?
It stretches or compresses it horizontally.
Bam, let's go. Stretches or compresses horizontally. horizontally. Let's go. Oh, yes. So for today, guys, that's all I wanted to do with the introduction of the parameter, the new parameter. We're going to do some more practice next time. But now I want us to move on to finishing off, looking at the functions and different forms where we need to rewrite them and see other little components that it's nothing biggie. But the new parameter for today was what? B, which is written 1 over B, which is the coefficient of X. So make sure you keep that in mind. Remember, 1 over B is inside of the parentheses as a coefficient of X. So just keep that in mind, okay? All right, so let's move on. Do you guys see a face in front of us, or is that me? Do you guys see it? Or am I just like crazy number person?
Oh, I see like a distorted face right there. Yeah.
Do you guys see it? Let's go. Josiel's making a face. Look at it. It's a face. My goodness. Anyways, let's move on. Copy this one on your new coordinate plane. We got example 2 mega q reads the graph of f of x equals x squared is shown. And it says, and on the graph, you have the reference points -2, 4, -1, 1, 0, 0, 1, 1, 2, 4. And then you graph your parabola through those. And then the next instructions are graph g of x equals -1 times f of parentheses 1 over 1x minus 3, close parentheses, plus 2. Copy that. I'll give you some time. Hurry up, please. Hurry, hurry, hurry. All right, so hopefully you already graphed this. And once again, it reads example 2 mega q. The graph of f of x equals x squared is shown. We already know that. There it is. It's a parabola. Then it says graph g of x equals -1 times f of parentheses 1 over 1x minus 3, close parentheses, plus 2. So first things first, before we graph the transformation, let's look at the transformation through the lens of our general rule, number 1. And number 2, we need to rewrite this without the little f of the f of whatever here inside of the transformation. Yes? Yes, Mr. Q. All right, so I'm going to write in blue right above here the general rule to see what we have so far. We got g of x equals, then we got a times f of 1 over b x minus h plus k. However, this is a quadratic, so where do I put that exponent of 2? Right here, right outside the parentheses. Exponent of 2, there it is. Okay. So that means on this one, I'm gonna write it here also, because it's what we're gonna transform right outside the parentheses. And let's match and see what we have and label our transformation. I'm gonna do that in red. All right. Who can get us started? Who can give me the first parameter that you want to label?
A,
A, which is what?
-1.
Okay, so I'm going to label that right here, A. All right. What else, John G?
K.
K, which is what?
2.
All right, so K, all right. What else, Alyssa?
There's B.
B, which is what?
1.
Okay. And Miles, you were chiming in. What else do we have?
I'm not sure.
Okay. Last one, Danny. What do we have?
H.
H, which is right here. Okay. So now that we have that,
It's not -3, huh? It's 3.
yeah, it's 3. Okay. So now that we have that, guys, let's rewrite our transformation. So here we go. G of x equals -1. Do we need the little f function notation? No. Do we have an h? Yes, so I'm gonna do a parentheses. What is 1 over 1? 1, so that means we don't need to write it. So I bring down the x minus 3 squared plus 2. What just happened, guys? That we no longer have a what? A b. So what did we just learn right now? That whenever we have the full form like this, we know that the numerator on where b is supposed to be has to be 1. So whenever b is 1, which is 1 over 1, we no longer use b. That means we're not going to do anything what? Horizontally. It's not going to do anything horizontally. So what is this graph going to do? Hayden, help us out. First of all, what is h and k going to do at the end?
It's gonna go up 2 and
Up.
to the right 3.
And right, okay. So we'll leave that at the end, which means now we need to deal with the multiplier of -1. So how do we do that, guys? We need a table. X, f of x for the original, and we just take the points. -2, 4, -1, 1, 0, 0, 1, 1, 2, 4. But we add a column now for the multiplier. And we have our multiplier -1 times f of x. Okay, so what is -1 times 4? -4, -1 times 1, -1, -1 times 0, 0, -1 times 1, -1, -1 times 4 is -4. I'm gonna graph this. -2, -4, -2, -4, -1, -1, -1, -1, 0, 0, 1, -1, 1, -1, and 2, -4, 2, -4. All right, and I'm gonna do a black graph for that one since I'm still not completely done. All right, if your little cousin walked in, what would you say happened to the original one? John Jeet?
It moved down.
What? This is the original. This is now the one we just did right now. We still haven't finished, but up to right there, what would you say happened, Jesus? What would you say?
It turned the other way around in a way.
Yes, it turned upside down or it flipped it, yes? So it flips it or it does the inverse. So make a note for yourself. Look up, guys, circle here where it has the A. Why did it flip? Who can give us the observation? Why did it flip?
It's a negative.
It's a negative, yes. So make a note for yourself. Asterisk, heart, whoa, heart, and just write whenever A is negative, you flip the function or do the inverse. But we're still not done, right? What's our last steps? We need to do H and K. That means 3 to the right and 2 up. We have the arrows right here. So let's do that for each of these points that we did at the end. So here we do 3 to the right, 2 up. 1, 2, 3, 1, 2. 1, 2, 3, 1. 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. 1, 2, 3, 1, 2. And 1, 2, 3, 1, 2. And we label that G of X. All right. All right, show me what fingers how come DR with these. Yeah, 5, 5, 5s, 4, 5s, okay. So one last thing, guys, and we're done. Sorry, we're taking the whole hour for this one, but we need it just to see the different views. This last one that I'm going to show you, you don't have to copy the graph or anything like that. I just want you to look at the transformation. Look up, please. Look at that. Same graph, same parent function, but look at the suggested transformation. So first, I need to rewrite this because this looks a little bit different from what we've seen. Yes? So notice that f of x minus 2 plus 3 is in the numerator, the whole thing over 2. So first I'm going to rewrite this by getting this 2 out of the way. How do we get it out of the way? Well, there's an invisible 1 here as a coefficient of the whole numerator. So that means this becomes g of x equals 1/2. 1/2. So you guys see it? The 1 and the 2? Which means that leaves us this whole thing to the side. F of x minus 2 plus 3. Now, can we rewrite this using our general rule? Yes. Now I just need to do is bring this power, write it there, and rewrite this. And I get g of x equals 1/2. Instead of the f, I just do parentheses, x minus 2 squared plus 3. And do we know what to do with that? Yes. Okay. All right, guys. Well, I hope so far we're doing well. I wanted to introduce the b parameter. Hopefully we got that far for today. And I want you guys to do extra practice with these transformations. Tutoring after lunch. If I don't see you, be there or be elsewhere. Have a good one. Peace. Bye.
Later, Miss Q.
Later.